I know we want to stay on schedule, so and invite Winn up because he's next on the agenda.
Are we on time?
Matt,
Are we on
thank
time?
you.
Yeah. Analog mode.
Oh, Lars?
Slides.
Yeah.
This is the one that you left here last year.
Okay.
I'll give it back to you.
Keep it.
It's provided all kinds of intelligence.
Cool.
I've been thinking.
Oh, no.
No.
Thanks, Lars. And I've been coming to some different conclusions. This is sort of my take on the way the world is. Real quick, it's broken. The security approaches that we've been doing are fundamentally wrong. Otherwise, we wouldn't be here and we'd be out surfing instead of having these kind of discussions. And I've been starting to look at things from an analog standpoint a lot more. A couple of problems that we've got. Obviously, digital is not binary, and I'm going to get into some of the thinking behind this. The purpose of this talk is not to try to convince anybody that I'm right about what I'm going to say. The purpose is that I've been thinking about stuff very differently, and if I can get you guys to start thinking with a slightly different perspective, maybe we can start coming up with different answers than what we have traditionally been doing. Political assessments. I was just over in Holland doing some stuff for some of those guys in NATO, and there was a huge disconnect between the concepts of what we're talking about technically and this digital mindset that also falls into the legislative process in every country. And how many times do we ever undo a law? How many times do we ever undo something? We tend to treat everything as a very, very binary function. And I want to fight that. So this was me young. I started off as an analog TV repairman and go across the street when we were allowed at 6 years old, go to the drugstore and take the TV apart, put it back together, just the way that I grew up. I also grew up handicapped. I'm colorblind. So I see the world very differently. And the Air Force wanted me to sit in the ass end of a B-52 because I can see through camouflage. So they wanted me to do that during Vietnam, and I politely declined, indicating Toronto was not too far from New York. I also have some other conditions which kind of get interesting. I grew up in complex systems, but they were complex analog systems, recording studios, broadcast facilities, lots of live recording where there were no, failure was not an option. When you have 50,000 people in a concert, and everything breaks, the show still has to go on. How do you do that? And this was part of also what helps me with incident response, in that unless you've got your plans, unless things are in order, and you've got some advanced thought in the analog domain, in the spectrum, and we'll get into that, you will find failure a lot easier. So analog. What is analog? And this group you're going to know, but a lot of the groups I talk to, they really don't understand. All I mean by it is something that is continuously variable. Instead of this absolute 1-0, continuously variable is all that it is. When people look at square waves over here, they tend to view those as digital. However, when you really zoom in on them, and kind of take a little bit of a fractal view, a square wave is really an analog function that is being approximated as a square wave. It's not absolutely a digital square wave. We do lots of averaging. We are an averaging machine. Computers are digital processors. This is an averaging machine. And we're starting to get these things to talk to each other. And averaging is just normal part of how we're doing digital music these days. It's all done with averaging into an analog domain from digital signals. You need to think more in a continua. In the military, we talk about how do we get from peacetime to wartime and all the stuff in the middle. But typically in the world that we live in security, it's an either or condition. We have Asperger's and autism. It's not an absolute. It's a spectrum of various levels of intensity. Same thing with volume sound. It's an analog function. DC to light, electromagnetic spectrum. It's not discrete. It's a completely analog function. And this is part of what I'm trying to get across to people, and hopefully it'll, over the next while, we'll be able to get you to think that way. Turn off absolutism. And the phrase I use is, I absolutely hate absolutism. And it's a recursive, convoluted way of thinking. We have to start looking at these problems very, very differently than what we currently are. I also grew up with a thing called synesthesia. I used to be in the record business. And when I was listening to guitars in the studio, this is what I see in my head when I hear music. And it's much less pronounced now than it was back when I was in the music business. But again, it was a complete analog in this case between what I heard and what I saw. So the internet, a lot of people say it's digital. I think that at the scale we've got, it's really analog right now. The idea of deperimeterization is taking away the concept of absolute endpoints, multiple devices, 4, 5, 8, 10, however many we have. This has become a blob, an amorphous blob that's oscillating and doing all these motions in 3 dimensions, sometimes in 4 dimensions. We don't need to look at it from an absolute digital perspective if we pull back our view, pull back the view and look at the whole as an analog function instead of a very specific endpoint at all times. But we need both views, just like quantum mechanics, wave-particle duality. Both are valid depending upon what you're trying to achieve and the level of granularity that you're trying to find answers from. The brain. This is an analog brain. That's what we are. We have very, very little digital capability. And Richard, you were addressing that just a minute ago. This is an averaging machine. We sort of kind of have some ideas now how it works. But as we get more integration going on between us and systems, okay, this lady, you may remember from CBS, she was complete quadriplegic, but now with hybrid technology, the interface of the digital equipment, the analog human mind, and full haptics, full feedback systems, she is now able to have sensory experiences in the real world by combining analog and digital processing. So
Snowden in the background?
Is Snowden in the background? Thank you, Joe. Well, she's the next director of NSA, so quite clearly. So let's look at what we've been doing. And right now, I tend to make the argument, we are TCP/IP, DARPA, 1969. It was an experiment. Now we're running the planet on it. We know it's broken. And over the next few years, we're going to add 50 billion more things to something that we know is broken. So we grew up on static security, siege warfare mindset. Maginot Line, that worked quite clearly. The Great Wall of China, that worked quite clearly. Berlin Wall worked quite clearly, right? I'm getting a lot of thumbs up from somebody who's being that. Is that your sarcasm sign, right?
You've got a family in the construction business. We build them.
And this is how, because the military was some of the first guys thinking about this back in the old days meaning the 70s, this was the approach that was used. And we took the approach of fortress mentality, let's keep the bad guys out. So we had gates, we had guards, we had dogs, and we had an asynchronous computer sitting off in a room and then a green screen, and that was our security model. And the security model that we used was fundamentally the reference monitor, the Bell Padula version, and then the Bibby integrity model that came up, which was very similar. Very simple kind of process. Make a decision, halt processing, make a decision based upon some set of rules, and have a go, no-go condition. In an asynchronous world from a single processor back in the 60s and 70s, this made sense. What broke everything was the concept of synchronous communications vis-a-vis the network. Things completely collapsed at that point. So back in the mid-90s, somebody mentioned DISA. Some people remember Bob Ayers from DISA? he and I had a meeting with some crazy Polish people in Warsaw. They never showed up. So what do two guys do? Drink beer and bring out a napkin. And Bob was working on a concept inside of DISA called protect, detect, respond. And that is what a lot of mantras are now being used today with the product vendors. We detect and respond, and most of them are full of crap. Just saying, they really are. Look. So the question comes down, is this vault secure? Is the safe secure? And in the physical world, we actually have a way of measuring and understanding how secure it is. Again, not a binary function, because we cannot say that that is absolutely secure, because there are ratings, and those ratings are based upon time, temperature, intent, and there's various other physical factors that can be measured. And we get some idea of the amount of protection, or the amount of protection that in this case, the physical device actually has. It gives us a reference point. And generally it comes down to time. In our world, we don't have that option. Right now, to get any vendor ever guarantee how long his firewall is going to work for? Joel, any guarantees in our field from anybody? No, absolutely not. So I started looking more at time as being a metric. So this firewall, how secure is this? This one is from England, Dave. It's from York.
We needed the railings during the war.
And it's a binary function, and they had every intention of putting them back, just like any change in any security system. So how can we rate the firewall? How can we rate any protective device? Going back to the Bella Padula model, which we're still using, fundamentally using these days, even though most security architects have never even heard of it. So can we rely upon protection? We know right now, because of the Chinese, the Russians, all the bad guys, we know that they're in our systems. We know that protection has failed. The traditional fortress mentality mindset doesn't work. It has some level of deterrence, an unknown, non-metricable level of deterrence. And for all these reasons, not going to work. Now, this jewelry store is protected by a pane of glass. Is that security? Is that security?
Yes.
Yes?
Yes.
How much security?
Compliant
Not
security.
Not so, but it is security, that pane of glass. Okay, how much security is it giving us?
a minimal amount.
Minimal amount?
It depends, because that window could be the first layer of security. There could be other layers of security behind that window. Once broken, it could be shutting steel doors, it could alert guards, who knows?
Wait a minute, is that security? Is that protection? Is that protection?
Wait. When you're saying security.
Is that
do you
protection?
mean- Do you mean prevention? Do you mean?
No, I mean prevention. That's protection, detection, reaction.
So prevention only.
That's all that is.
It provides a great psychological barrier for those who might not otherwise attack.
Keeping the good guys honest.
Security is an emotion anyway.
Keeping it exactly keeps the good guys honest.
I don't need the glass in Saudi
Sorry?
Arabia. I don't need glass in Saudi Arabia.
You don't need it
You don't need the glass in Saudi Arabia.
because they'll cut your hands off. But what can we measure? In our networks right now, assuming you've got a SIM and an IDS, IB, any of the reasonable technologies, we can measure two things. We can measure detection. How long does it detect that window being broken in the physical world? How long does it take to detect it? Then the second component we can measure as well is reaction. How long does it take the cops to come? And we have a number. And that number in this case, I'm suggesting we should use is time as being that metric. Now, simple formula comes out of this. And this is the stuff that Bob had given me some ideas on. This was 95, I think it was. Protection measured in time, detection, reaction measured in time. If the amount of protection that pane of glass has, or whatever the protective device is greater, guaranteed greater, than the amount of time it takes to detect that glass being broken, added to the amount of time it takes to react and mitigate it, I then can mathematically say I have a secure environment, assuming that protection is measurable and provable. But we know we cannot do that. So what we end up with is an exposure issue. And this goes back to Cold War. We knew that we could detect a launch from the Soviets, few milliseconds, some really short period of time. Then we have 18.5 minutes to make a decision. What are we going to do? But we knew how to detect. Reaction gave us a window, and then the protection became an open question of exposure, which was what MAD was all about. So many cases we've come from manual defense.
Only thrown, the amount of your window of time depends entirely on the adversary's capability and intention. How long it takes for them to affect an action in your environment for the objectives they're seeking.
That's one way of looking at it. If you're looking at it from a strict attack defense standpoint, that's correct. I'm trying to raise it up higher to another layer of abstraction. We can get down into the granularity, but I'm trying to get it up a little bit higher first. So we have automatic and defensive techniques, and the only thing that shows is that when you do something automated, it's going to be a lot faster than involving a human in the process in the detection and reaction mechanism, and something interesting happens here. When you speed up your D+R time, the vulnerability to specific assets within the organization gets smaller because file size and bandwidth are all dividable by time as a common metric. So what we end up with is, since we don't know protection, we know we have an exposure. The exposure time is the worst case of your detection and reaction. And that can start giving us evaluations of what my risk is, and then the risk people can go sort out the money on the back end of it. Of course, we need, I think somebody mentioned data classification. Again, we tend to today treat our networks as a binary function. I got to protect my network. Which part? Oh, the whole thing. Well, we know that doesn't work. Well, which parts do you need to protect? Well, the crown jewels, the Coke formula. Well, where is it? Well, I don't know. It's somewhere on the network. So we got to protect the whole damn thing. And it goes back into this circular logic, and we end up treating everything, the networks, as a single object with some enhanced security places occasionally. But the general model has become, unfortunately, look at it as a single box. So which files then become vulnerable? Again, this is math, and everybody can have the slides later on. I don't want to go through all the math right here. Defense in depth. When the house at the top of the hill is going to get robbed, bad guys, what's one of the first things they're going to attack? Security system, the alarm system. And again, having multiple layers of this formula work depending upon how far you're trying to go. Now, let's do it a little electrical here. Simple electrical circuit in the old days was how we made dimmers. And it was just varying a simple formula, I equals E over R. What if I take that same concept, except do time equals file size divided by bandwidth? How many of you have bandwidth compressors in your networks? Meaning, should, when an attack is going on, when a security event is going on, should your only alternative be to turn it off? Or are there middle grounds here that I don't want to turn off my public-facing commerce site, but maybe I can slow it down a little bit in order to give my detection and reaction mechanisms additional time, reducing the risk by using a simple corollary formula to what we have done in the old electrical world. Spencer.
Do you mean like a tar pit, or do you mean like drop?
Bandwidth compression. In other words, instead of
1200 baud instead of 200. Okay.
and here is what ends up happening. When you do bandwidth compression, you have orders of magnitude of additional layers of security based upon file size. Again, it's in the time domain. You can look at this very simply and divide by time in order to understand where certain levels of vulnerability are. And in this case, I'm doing extricated data. and just doing some simple math on what happens when I compress from a gigabyte per second to 100 meg per second. Do I need that speed for everything I'm doing? Do I need that speed to stay in business? Or will reduced speed be acceptable while I'm doing mitigation? So bandwidth compression is something that I'm suggesting we begin to look at.
So we're already seeing adversaries doing things like compressing data exfiltration, moving into higher bandwidth exfiltration points,
Mhm.
playing with windows of exfiltration
Yep.
when more bandwidth is available.
Yep.
I mean, so clearly we'll have an effect, but the adversaries are already compensating for that.
Well, you can't compensate, you cannot take, if you compress, as G-Mark just said, if you take my internal network and I compress it to 1200 baud, the bad guys aren't going to speed up data transmission. They may have a big ass pipe on the back end of it, but they're not going to speed up data because they're not, unless they have control over your bandwidth compression internally. And that's where the defense in depth comes back into the deal under a detection reaction mechanism, because the bandwidth compressor would be in that particular circle.
So, Winn, I would agree that you've got to start looking at some of the challenge with some of the, say, Defense Department, right? So you can go on, and right now, Cybercom claims that they're not going to unplug servers when they're attacked. They're going to continue through the attack. The challenge with that is that they're looking at bandwidth compression, but they're doing it on a very knife's edge, where what happens is that they can slow the attack a little bit, but that gives them a false sense of the impression that they have time to now mitigate the problem. And this comes down to education and other things which they simply are not doing, and that becomes an issue. The other issue is that when they look at the compression piece of it, they start to just basically kick out programs, and they'll say, okay, no more streaming video, and they'll kill it. Well, guess what a predator is? Oops.
I'm not, again,
I'm just throwing that out.
no, I fully agree with you. It's how you view the world with a different prism. And all I'm suggesting as I go through this is we use an analog prism, and in some of what you just said, they're still responding with a digital response.
Correct, and the leadership above doesn't understand what you just said in 3 slides. They don't get that, so that's all they're trying to do.
But this is your job now.
Exactly. I'll get right on it.
Thank you, Hans. All right, so with that in the beginning, and this is the work that Ayers and everybody had, one of the things that really, really, really pisses me off is that we still have root. We still have root control of systems. And I started thinking about it and said, why after 50, 60 years do we still have this? And how do we get around it? Sorry?
Kill Bella Padula.
Well, we're going to work with Bella Padula without killing either one or without killing Bibi. We're going to get there. So the way the world works is we have binary trust. I trust the guy. I don't trust the guy. He's a trusted insider, right, Joel?
Oh, yeah.
This is the way we do it right now, except it gets much worse than this because we don't look at it as an analog function. We rate people yes or no. We give them the keys to the kingdom or we don't. What we don't do is do an appropriate level of vetting and weighting and understanding something that we don't use called trust factor, which should sit min-max. Now, I grew up analog, and we had recording consoles. We have an equalizer. And what we would do in order to make sure stuff worked is twist it all the way down, all the way up, and then another knob all the way down, all the way up, to understand what happens in that particular environment. We're not doing that in our environment because we have this binary switch. So we need to start looking at it as an analog function with trust. And this is going to end up meaning something in a couple of slides. So the real world, though, when we give somebody root control, we don't give one guy root control because he can't be there 24/7, 365. So we give 5 guys root control, some number. And what that gives us is a logical Boolean OR gate, meaning Bob, Sue, any of them can get on there and make the changes as an admin. Enterprise, really, some number of people, and we have an OR function. But what ends up happening when you apply trust factor, and I'm going to say, okay, at this first admin, we're going to trust him 0.9. But the second admin, what do we trust him? 0.5. In this case, we can show, and this is just probabilistic math, nothing really complex, that now my security, my trust, is lower than the weakest link, which changes our entire perception of how we're looking at trust. Now, this doesn't solve anything yet. Again, it's a different way of looking at things. Now, how do we solve this? Well, we can go to something called the two-man rule.
But the question is, how do you identify and put that level of trust? How do you get that number?
That is going to have to be something that is self-consistent within a specific organization. Your set of criteria is going to be different than Lars's. It's going to be different than his.
Yeah, but you're gonna say, you know,
I
or the vendor that had Snowden on there, there were 1,000 admins on there. And how do you rate Snowden, you know, a 0.4 versus someone else a 9?
It has to be an internal set of criteria with your own weighting that you're going to set up.
Be sure, no. Alexander was asked last week, what would you send Snowden? I'd send him a copy of the oath tonight that he signed. That's the problem, isn't it?
In the government and mill world and in the IC world, yes. In the commercial world, same question, different way to resolve the answers. And again, I'm not saying telling you how to resolve the answers. I'm looking at an approach to look at the problem differently. So
If we could go back one slide, if I might suggest at the bottom line here, the total trust factor should probably be an average and not multiplication. So I'm saying 0.9 plus 0.5 divided by 2.
we'll go over that later. Let's not get that granular, but let's go do that. I've been playing with this for a while, but I'll show you the logic behind it later. So the two-man rule, we're used to it. Sometimes you got to sign two people have to sign a check. We're used to the two-man rule here. So why don't we apply the two-man rule in our networks? Well, that creates an AND gate. Very, very simple. What's the fundamental problem, though, with running an AND gate in my admin? Time. Who said time? That's it. Because this guy may make a change or affect something, but we got to wait for him to agree. So suddenly those urgent responses, those urgent things that we want to have happen inside of networks of any sort of control, it doesn't matter what the application is, I have a time problem. So how do I get around that? I grew up, again, analog, and the concept of feedback. We're all used to the OODA, and that's essentially a dynamic feedback loop that Boyd came up with many, many years ago. And it works in the military, it works in market research, it works in product design, it works in many, many different aspects where you have to do improvement. And a lot of this is what helped with the Japanese and JIT, just-in-time delivery, back in the late 80s, early 90s. Now, the other thing that we can do is when we look at it, I call it squeezing the loop. Here is the first time we try something, second time, and all we have here on the XY matrix is time. All I'm doing is squeezing the loop. I want that loop to be as fast as humanly possible in order to maximize the efficiency of the operation and minimize the exposure and risk that we go back to the prior formula from. Defense in depth creates small OODA loops. Just because I've got one OODA loop with my observed, do I only have one binary observation criteria, or do I have many observation criteria, each that have their own OODA loop built into it? And this turns it into a self-similar way of looking at things from a fractal standpoint, which has some interesting consequences down the line as well. Now, in feedback, this is the mechanical version. It's a governor, started in steam engines. Electrical stuff, yesterday you heard the feedback from here to Morocco, and that's an acoustic mechanism. All amplification circuits are based upon feedback. And then the abstraction model is here. What this does, the fundamental reason for feedback in any of these environments is to create a sense of equilibrium, to keep things from getting out of control. A runaway condition, whether it's in the physical, electrical, or acoustic criteria. In our world, we don't have very much feedback going on. So we know that haptics, we know that learning, it's all feedback based completely, because we are feedback based at the way brains work and the neurons are working. It's not digital memory. It's a constant feedback loop, continuously learning and changing. So what would happen if I added the feedback to the module? And my feedback mechanism here is going to be the analog function of time. So all we're saying here is that there is some process, some request, something is going to happen. So that request goes through. But because I want to have the two-man rule, it has to be authenticated within some specified amount of time. And the second trigger is a decrementing clock based upon policy. If the approval does not occur within that specified time, there's revocation, which gives us a get out of jail mechanism when a bad decision is made. Now we can apply this in many, many ways. Here's another way of looking at it. He makes a decision, triggers the clock, and Bob has X amount of time. Otherwise, the decision that was originally made is revoked. Automatic revocation when approval does not occur. We see the failure in legislation. We see the failure in so many places in the real world, and why it's not working in our world right now. So this is the abstraction model for doing this. We can do it I like to do it in I&A mechanisms. You can do it in crypto. You can do it through access control. The fundamental abstraction of putting an analog feedback into a digital decision-making process is something that should, in my opinion, be very fundamental, whether we're talking at the code level or all the way up the stack and even up at the BGP level. So in our world, anybody recognize what this circuit is? All you EEs, John? It's called an RS flip-flop. What it also is a bit of memory. It's simple diode logic. And what happens is when I do a set, I go high, do a reset, I go low, and it's just the inverse functions. So it is a memory circuit of one bit of information. This is how we're running the world based upon a sample truth table down there. Now let's change this up a little bit and look at this circuit slightly differently. There's my fundamental flip-flop, but I'm going to take the output feedback mechanism into a decrementing clock whose time value is set by policy. And I end up with a fundamental circuit that gives me another answer with another set of truth tables that are based upon time, and allows me to look at the world slightly differently than I currently do. And I'm arguably calling it a time AND gate for now, and I'll hopefully come up with something better than that. But logically, it ends up being very, very interesting, especially when you consider nukes. How do you launch a nuke? Anybody? Turn them at? Simultaneous. No! There is no such thing as thank you for that. There's no such thing as simultaneous, except for quantum entanglement. What happens is this. There's the launch nuke circuit, and the two countdown clocks, either of the guys who's the one that killed 20 million people, triggers his own time clock. The other guy, if he clicks first, triggers his time clock. And both events have to occur within a specified policy-driven amount of analog time. It's a time window. Again, a min-max condition. So now let's take one more thing that I grew up with. I showed you the circuit earlier with the volume control, and it's a potentiometer in the feedback loop of an amplification circuit in order to maintain equilibrium. Simple enough. As we started going into automation in the audio industry in the 70s, and how I met the blonde lady who's tolerating all this shit, we decided, oh, we're going to run a computer for audio. Oh, cool. So in order to do that, we had to create an out-of-band condition. Normally, you have the audio and the volume control, the control in one circuit. Similar to the way we're running TCP/IP right now. We have data and control down the same hunk of wire, which is really good with a backdoor attack, of course. So what was done in the audio industry is to set an external voltage control over the amplification in a separate control circuit. If something goes wrong with the control circuit, it was fine. The volume would remain the same, no major impact. How much of this are we doing in our world right now? We're not doing a whole lot of out-of-band communications whatsoever. So in a high sensor-based network, which is where I grew up, we had audio sensors and control sensors everywhere in these control consoles and the communication between them and the tape machines and all the bits and pieces. We don't have that in our world here. So another way of looking at this is, number one, we talked earlier, you have to have a decision matrix. You got to kind of have some idea of what are you trying to do. When something goes wrong, what should the response be? And we've all sat in organizations, and Matt, you probably more than me, something goes wrong and goes, well, we got to go call the CIO, and then we got to call the lawyer, then we got to go call the police in order to figure out what we're going to, and time, and you create a chaotic condition versus having some prescribed set of criteria that are somewhat predictable, as Matt was saying, and have some sort of initial response, whether it's time compression, shut it off, what is the response going to be? So we can have single reaction channels, and the point here is that that reaction matrix and the reaction channel is not part of your normal TCP/IP infrastructure. It's a plugin in an external out-of-band security control channel where your security detection and reaction mechanisms take place. If they all go down, your infrastructure is still going to work the way it does today. But with a reaction matrix running things external to the conventional control and information circuits, we have additional capabilities depending upon the nature of attack. So in this one, I have two reaction channels, one running perimeter stuff, one running internal stuff, and I can create a feedback mechanism in there as well by having reaction channel 1 feed back to my other reaction components and up sensitivity in a dynamic mechanism. And those criteria entirely up to whoever's going to be designing these products in the coming years, because I'm certainly not going to be designing products. Now, a couple of interesting things happen out of this. Let's go sit at the code level. Let's go up to the highest level. And there's some number of service providers around the world. And high-level routing is a limited suite. It's a limited suite of connections for optimal connection, optimal traffic. What if every single ISP had a reaction component saying, I'm under attack? And instead of trying to communicate back down the main pipe where information and control signals are, it says, I'm going to go out of band and I'm going to call the next hop. And this next hop's detection is saying, reaction is saying, oh, you're seeing traffic XYZ. What do you want me to do? Stop that traffic, hop number 1. So initially, using out-of-band communications without having to go through all the big data analysis, I don't like what I'm seeing, please stop it. Now imagine this occurring with every ISP. What happens to denial of service? What happens to spam? If everybody's cooperating and I have an out-of-band circuit, I have complete security controls, communication going out of band, outside of my primary channels, and in some period of time, depending upon how it's all constructed, and if everybody's playing nicely together with a new protocol, an out-of-band security protocol, I can then start getting at the source of CNCs and botnets and spam houses, hop by hop by hop, without all the phone calls that are going on right now.
What you're saying is you cannot run the radio.
Sorry?
You cannot run the radio. Hop one, see if you speak, keep the radio ahead.
It's exactly it. And again, that's a time component in the physical domain on a highway. And I'm saying if every ISP cooperates, it's fairly simple, whether I'm operating inside my network or not. Here's my normal traffic. Everything's running smooth. That's where we are today. We're not going to rebuild the existing infrastructure. Right now, we're bolting on, but we're bolting on inside of this infrastructure, not external to it. And I'm suggesting that we create an external out-of-band security protocols that'll have various criteria, and I'm not qualified to design what those are, but maybe there's one operating at the gateway level. There's another working at the code level, working within networks themselves, inside of organizations. Then I want to take one more step. I want to add negative time. I was watching John's face here. He goes, what the hell are you talking about?
No, I'm just trying to figure out the out of band thing, how it's gonna work.
That's your job. Again, that's not my job.
Well, after everybody's playing nice and cooperating.
That's my point.
Well, yeah, again, it's a protocol. If the presumption of the protocol in out-of-band communications is correct, and arguably from a highest level, abstraction level it is, get everybody to play. Somebody's going to productize this.
I hate to say it, there already is a product that's out there that's doing this, and it's in the world right now, it'd be perfect.
Then bring it on. We'll talk about that. Let me just finish this up with negative time. Right now, what we're doing very often is we'll have our data traffic, and then we've got our IDS, and then we have our big data. So now we're going to study all of this big data. Oh shit, that's what's going on. But it's still going on, and I'm reacting after the fact. Does everything have to happen close to instantly? There are many cases when the answer is absolutely no. So if I know that my detection and reaction, and in this case we'll call it an IDS and a big data analyzer, for example, in a malware environment, why does that traffic have to go ahead of the decision being made by the big data? Why don't we do what we did in the audio business? Delay it a little bit. Does everything have to go out? Does that email that is being sent out have to go out that very microsecond? Or is 100 milliseconds later, after analysis, acceptable? Who's going to know the difference? Point is that if I take some delay over whatever traffic I choose, and I delay it the exact amount plus some nominal constant of my detection and reaction time that's measurable, I go back to my original formula, and I now know with my delay that my protection time is greater than my protection time is now greater than my detection and reaction time, giving me, in theory, if John's able to build this, provable security. That's the concepts I've been working with for a while. What else can it do? Every time I talk to people, they say, oh, you can take that idea and do this. You can take that idea and do this. And that's the exciting part for me, that I've kind of got some ideas and people are starting to grab on. I'm looking for holes in it. And the fundamental thing that I'm trying to get across is these have become my new mantras, new ways of thinking. And slides will be available to everybody, of course. And they tend to be analog. And what has happened for me, nothing else, when somebody talks security, I'm no longer thinking in these absolute ones and zeros. Everything has become a continuum for me. And that whole kind of lawyer question, gotcha. Well, just a yes or a no, sir. Well, tends to be, especially in geek world, well, it depends. Well, it depends is an analog answer, not a digital answer. And I'm hoping that to get people to start thinking with a different viewpoint and with just a different filter. So analognetworksecurity.com, where Haley is here, going to be doing wonderful things with it. Yeah. And it's hopefully just a different way of thinking. So thank you very much. I appreciate it. I love the confused faces. That means a lot to me. It means I'm making you think. And Joel.
Let's say it works. How high level can this be applied?
I look at the two, again, min-max. At the code level, I've done a little bit of code with it. I'm no coder, but there are some programs out there from Purdue, actually, that allowed me to put in logic tables, draw them out, and then code is generated. So I look at it from the code level, and then ultimately, the other extreme is that the tier one guys. Again, it's an abstraction concept, not a product. It's just a different way of looking at the universe.
Has DARPA seen this?
I don't know. I mean, I've only started presenting this 3 weeks ago.
They haven't done, okay.
At any rate, thank you. Let's take a fast break, and then we're gonna hand everything over to Sweden for a couple hours.
Yeah.